Alright, we are going to learn today how to solve systems by elimination using multiplication. So we've already learned how to solve systems by elimination using addition and subtraction. Today we're going to learn the multiplication piece. And then once we've done that, we'll determine whether there's one solution, no solution, or infinite solutions. A system of equations is two or more equations. We've gone over this quite a bit. No solution. There are three different kinds of solutions you're going to get to a system of equations. The first one is no solution. The second one says one solution. The last one is infinite solution. A no solution occurs when the two lines never intersect. They have the same same slope but different intercept. One solution occurs when the lines intersect or they cross, and they will meet at that one point. We will be looking to identify that one point. And if you notice that the slopes are different, that means that eventually those two lines will intersect. Infinite means that you're going to graph a line, and if you graph the second line, it graphs as exactly the same line. These two lines will have the same slope and intercept. So to solve using the elimination method, these steps are the same as yesterday's assignment. You will choose a variable to eliminate. You'll create opposite coefficients. Today when we create opposite coefficients, we'll be using multiplication to do that. So if I have a 2x and a 3x and I want to make it so that these two are opposites of each other, I would multiply this top one by a 3 and the bottom one by a -2, so that this would become 6x and this one would become -6x. Here they are opposite coefficients, and once we have established that, then you'll go ahead and add the equations. Next, you will solve for the remaining variable. This will be done by by multiplication or division. You're going to substitute the variable that you just found in step 3 into either equation and solve. And then the last thing you'll do is check your solutions for both equations. So here's our system. We're going to solve this. The first thing you're going to look at, as I always say, is it easy for a 2 to become a 3 by multiplication? And we can see that no, that's not very easy, but can a 1 become a 5 by multiplication pretty easily? The answer to that's yes. So what we're going to do is we're going to multiply this entire equation by a 5, so that we have 5's here and one of them is opposite. So when we get that 5, we distribute it to all of our terms and we rewrite the equation. I'm going to write it right to the side. So I multiply the 5 through and I get 10x minus 5y equals 30. Then I'm going to rewrite the bottom equation. I don't have to change it at all. 3x plus 5y equals 22, and then I'm going to look to make sure that I've created opposite coefficients. As you look right here, you can see that one's a -5, the other is a +5, and they are opposite coefficients. So once those have been created, you go ahead and add, and we're going to add straight down. A 10x plus a 3x gives us 13x. These two will subtract out, or they eliminate themselves, and then we get 30 plus 22 over here to give us 52. To solve this, we divide by 13 to both sides, and x equals 4. So we have half our answer. To get the other half, we're going to choose one of the equations, and I'm going to go back to an original equation. I'm going to choose the bottom equation because I haven't done anything to it. And when I choose the bottom equation, I'm going to go ahead and substitute x in. We just found x to be 4, so I'm going to substitute that in. Plus 5y equals 22, and then we'll solve this. 3 times 4 is 12. Next, you'll subtract 12 to both sides, and those subtract out. You get 5y equals 22 minus 12 is 10. Divide by 5 to get y by itself, and y is 2. So this will tell you that you have one solution located at 4, 2. The last thing that you want to do is check your solution. So we put both these values in. The first one is 2 times x, so 2 times 4, minus y, which is 2, and this is supposed to be 6. So 2 times 4 is 8, minus 2 equals 6. It checks in the first one. The second one, we have 3 times x, which is 4, plus 5 times 2, which is y, and that's supposed to give us 22. So we multiply those. 3 times 4 is 12, plus 10, and that does give us 22. So it checks in both, and we know that this solution is correct. What this solution means is that if we were to graph those two original equations, that they would intersect at 4, 2. B is a little bit more complicated because as you look, is it easy to make a 3 become a 7? No. Is it easy for a 4 to become a 5? No. So when this is the case, I look at opposites. Right here I have opposite signs, so I don't have to work too hard to create the opposite. But then I have to make the y's become the same number, just opposite. So to do this, I'm going to take this 5 right here and multiply the top equation by it. So I'm going to distribute, make sure that 5 goes to all 3 terms when you're multiplying. So we get 5 times 7 is 35, minus 4 times 5 is 20, equals 5 times 17, which is 85. Now the bottom equation, we have to work with it as well because I need this 5 here to become a 20. So I'm going to take this 4 right here and multiply through. I'm not going to change the sign because right now they will already be opposites. 4 times 3 is 12. 4 times 5 is 20. And 4 times 14 is 56. Now I created opposites right here, which is exactly what I wanted to do because I've created opposites when I will go ahead and add these two equations. So 35x plus 12x gives us 47x. These two will subtract. And 85 plus 56 is 141. To solve for x, we divide by 47. 47's divide out. X is 3. So we're going to use that value and go into either equation and solve. I like to look for the equation that has the least amount of negatives. So that looks like it'll be the bottom equation, and I'm going to go to an original equation. So I'm going to take 3 times my x value, which we just found to be 3, plus 5y equals 14. 3 times 3 is 9. And then I'm going to move the 9 to the other side by subtracting. You get 5y equals 5, divide by 5, y equals 1. So this tells us we have one solution. The two lines will intersect at 3, 1. Your last step is to check them. I'm kind of out of room, so I'll try to do it over to the side right here. So I'm going to take that 7, multiply it by 3, subtract 4, multiply it by 1, and this is supposed to equal 17. So 7 times 3 is 21, minus 4 does equal 17, so it checks in the first equation. Second equation, I have to take 3 times 3 plus 5 times 1, and this is supposed to equal 14. So 3 times 3 is 9, plus 5 is 14, so it does check in the second one. That means that this solution is correct. Now there are some special cases when solving systems using the elimination method. If I wanted this 3 to become a 6, I would multiply it by 2, but I don't want it to become a 6, I want it to become an opposite, so I'm going to multiply it through by a negative 2. Now make sure when you multiply this, it multiplies to all 3 terms. So on this equation I will end up with negative 6x plus a negative 4 or minus 4y equals negative 2. That top equation can remain the same. So it's still 6x plus 4y equals negative 1. At this point you're going to add. Because we have opposites, when we add these, they go to 0. And I add those, they go to 0, so I'm left with 0 over here. And then I have negative 2 plus a negative 1 to give me negative 3. Now, this is not true. So when this is not true, we say this is no solution. And this occurs when you lose both variables, and then the statement is not true. As we look at the second equation, same idea. I want to get these x's to be opposite, so I'm going to multiply by -2. I get -6x plus a -4 or minus 4y equals -2 times -1 is 2. Then I'm going to rewrite that bottom, or the top equation right below that. And because I have opposites, sorry, that wasn't very clean. Because I have opposites already with my x values, I'm going to go ahead and add. When I add, these go to 0, these add to 0, so I have 0 over here, and these as well add to be 0 here. This statement is true, so this indicates that they are exactly the same line, and so they have infinite points in common. So infinite solutions. Can you solve, I talked about this yesterday, but as a review, can you solve 0 equals 3x? Yes, you can. What you would do here is you would divide both sides by 3. So the 3's would divide out, and 0 divided by 3 is 0, so x is 0. So yes, you can solve it and get an answer. Second one, can you solve 0 equals 3? And the answer to this is no, because these are not equal, and this is what would indicate that there is no solution. Alright, that should help you with your assignment 5.3, solving systems of elimination using multiplication.